All right, hello and welcome to Lesson 1-4, Write Equations and Inequalities. The first thing you have is a chart. I would like you to fill out the chart below. Let's go through this. First symbol I'd like you to put in your box is equals. Obviously the meaning is equal to. And besides the associated words is equal to, you might have the same as. And if we can think of any others, we can maybe generate those tomorrow. Okay, the next symbol is a less than, and the reason it's called less than is because we read inequalities from left to right. And it would be this side is less than this side, because we read from left to right. That's why this is called a less than sign. So you might hear is less than or fewer than. This one is obviously is less than or equal to. This line right here underneath the less than sign adds that little bit equal to. Okay, so you might hear is less than or equal to, or you might hear in a word problem at most or no more than. So those, if you see these two phrases right here, you're going to use this symbol right here. Obviously this one would be greater than, and again, because we read from left to right, this side is greater than this side. Okay? The words is greater than, and you also might hear just more than. And this one obviously is greater than or equal to, and besides this phrase right here, you might hear these phrases at least or no less than. You're going to be having some word problems throughout this video, and so keep in mind these phrases and which symbol. So you can refer back to the chart in your notes as we go through this. Okay? All right, next page. Our first examples, writing equations and inequalities. So we're going to take the verbal sentence that's on your page, and we're going to write an equation or an inequality, whichever it calls for. So the first example, A. The difference of twice a number k and 8 is 12. Okay, we worked on our phrases yesterday for the twice a number k, so we would know how to write that expression, twice a number k and 8 is going to add, making it an equation versus an expression. So we're adding that is, which means equals, okay? So is always means equals. That might be a phrase you want to add to your box here. So we go back to this page, if it'll go back for me. And you might just write in the word is. Okay? It's an associated word for equals. Is always means equals. So now we can continue on. Okay. Here would be how we would write that. Twice a number k. Twice means 2 times. A number k is your variable, and means plus. Oh, sorry. Just scratch that. I forgot. Difference is up here. Geez, great teacher there, right? The difference between them. So since it's difference, the 2, that looks like 2x. Let's make that. I'm just being a great teacher today. 2 times. Let's put a dot so it doesn't look like a variable. 2 times a number k. So the difference between this, so that's why it's first, and 8, that's why 8's second, because of the word difference, is means equals 12 is our answer. So that's how you change the verbal sentence into an equation. Let's try the next one. The product. Okay, what does product mean? Product is going to mean multiply. Okay, so the product of 6 and a number n is, well, there's that word is, but it's followed by the words at least. Okay, a number n is at least 24. So here would be the inequality we would write this time. An equation has an equal sign. An inequality has the greater than or less than signs, or the equal to signs as well, greater than or equal to, or less than or equal to. So the product of a 6 and a number n, here's the product, 6 times n, is at least 24. In other words, it's at least 24 or bigger. So greater than or equal to 24. Okay? And C. A number y is This is a toughie. A number y is no less than 5. So it can't be less than 5. If it's not less than, it has to be greater than 5. And no more than 13. So in other words, it has to be greater than 5, but less than 13. So how are we going to write that? All right, here's how we write that. Your y goes in the middle because the y has to be greater than or equal to, no less than 5. So it can be 5, it just can't be less than 5. Okay? So y would be greater than or equal to 5, but less than or equal to 13. It can't be more than 13. It can be equal to 13, but not more than 13. So does that make sense? So that's where you have to kind of just pay attention. Okay? So this shows that y is greater than 5, but it's less than 13, and then the equal to. Okay? All right, pause the video and do the guided practice. It's just one guided practice. It's on your page, and there it is. Write either an equation or an inequality, whichever it calls for. Here's your sentence. The quotient of a number p and 12, quotient of a number p and 12 is at least 30. So pause the video, write your sentence. Okay, there's your answer. You should have p divided by 12 is greater than or equal to 30. Okay, from this point, if you have any questions, write them on your notes, circle, star, whatever it takes to remind you of what questions to ask me. All right, example 2, checking possible solutions. Instructions say, check whether the given number is a solution of the equation or inequality, whichever is given. And you have these on your page. Your notes say, sometimes substituting in certain numbers for the variables ends up making the equation or the inequality false. When it is false, it is not a solution. So let's do a couple of these. All right, first, here we go. 8 minus 2x equals 2. So this is an equation, and they want us to substitute the 3 in. That's what they want us to use the 3 for x. So when x equals 3. So substitute that in. And we ask ourselves, 8 minus 2 times 3 equals 2. So we solve it. And 8 minus 6, because 2 times 3 is 6, 8 minus 6 does equal 2. So 3 is a solution to this equation. 3 makes that equation true. Letter B. 4x minus 5 equals 6. And again, our number is 3, so we substitute that in. 4 times 3 is 12, and 12 minus 5 is 7. 7 does not equal 6. So therefore, 3 is not a solution to that equation. Okay? Letter C, 2z plus 5 is greater than 12, and then we use 3. Now, you guys, the semicolons are not part of these equations. They are just showing you the end of the equation or the inequality and the number you're substituting, just FYI. I had students last year that was like, what does the semicolon mean? It doesn't mean anything except that it's the end of the equation or inequality. So let's substitute a 3 in for our z. 2 times 3 is 6, and 6 plus 5 is 11. So therefore, 11 is not greater than 12. So 3 is not a solution to that inequality. And this is pretty simple. So go ahead and let's do D. B plus 5 is less than 15. Substitute the 7 in. 7 plus 5 is 12. And 12 is less than 15. So it is a solution. Pretty simple. So as you go through your homework today, and if these are your instructions and you're not sure what to do, refer back to your notes. Okay? All right. Use mental math to solve an equation. Now this is pretty easy. This is before we get into actually manipulating equations. And mental math is just literally some of the equations are simple enough to look at and know what the answer is. Okay? So here's our first equation. X plus 4 equals 10. Obviously we can think, what number plus 4 equals 10, and we would know that x would have to be 6. And then you can always check it if you need to. 6 plus 4 is 10. And you can do that mentally as well. Okay? Does that make sense? Just think about it. What plus 4 equals 10? So next one. 20 minus y equals 8. So you could always do the reverse. Or 20 minus what number equals 8? Maybe you could do 20 minus 8 equals what? But 20 minus what gives you leaves over 8, or leaves 8. And that would be 12. Obviously, your mental math, hopefully you know that. And then you could check it if you needed to. 20 minus 12 equals 8. Okay? Letter C, 6n equals 42. Well, ask yourself, what times 6 equals 42? And hopefully you know your math facts well enough to know that 7 times 6 equals 42. And then D, A divided by 5. Now please get in the habit of seeing fractions as division problems. See them as division problems, and this is a variable divided by the number 5. So ask yourself, what number divided by 5 equals 9? And hopefully you know, again, your facts well enough to know that 45 divided by 5 equals 9. Okay? All right, so there we go. There is kind of like what you could do with using some mental math. I love equations that are that easy. It's nice to have them. They won't all be that easy as we go through the year, I promise. All right, example 4, solving a multi-step problem. All right, let's think about this. The last time you and 3 friends went to a mountain bike park, you had a coupon for $10 off, and you paid $17 total for 4 people. What is the regular price for 4 people? If you pay the regular price this time and share it equally, how much does each person pay? This is a 2-step problem, and why? Why is it 2 steps? And I want you to think about that before you write. Think about why it's 2 steps. Okay? Hopefully you can come up with an idea. Okay? The first thing, I'm just going to tell you why. The first thing says, the last time you went, you had a coupon and you paid $17 for all 4 people. Okay? So, first of all, you have to find what the regular price for 4 people is. And then, if you pay that, how much would each person pay? So, you have to find this information to find this information. So, it's a double-step problem, and that would be why. So, you have to think about your ultimate goal and how you get to the ultimate answer you're looking for and what you need to get this answer. And then we don't have the regular price here, but we have information to find the regular price. Okay, so let's go ahead and skip through here. We're going to write a verbal model and let P be the regular price for 4 people. And we're going to write an equation. So regular price, take away the amount of the coupon equals the actual amount we paid. So that's where we think things through. Now you guys, I know this verbal model really seems easy for you. It probably seems very simple. And you're like, why do we have to write this, Miss Baynes? And these equations are very simple for some of you possibly, and maybe some of you don't think they're simple. However, when we get into much more difficult word problems, it's nice to write down in words kind of what we're doing. And then it helps you go back to the problem and figure out what you know, what you don't know. We don't know the regular price. That's why we're going to make it P. We know the amount of the coupon. We know it's 10. And we know the total amount paid after that coupon was 17. So there's the kind of stuff that once you write those words out, you can go back and search into your problem for the numbers you need to substitute in. So there we go. So there's our first equation that we need to find the irregular price. So we're going to use mental math because we should be able to know what minus 10 gives us 17. We should not need a calculator for that. And if you do, you might rethink the algebra class. Just saying. Okay, so you think 10 less than what number is 17? So obviously we know the original price is $27 for 4 people. Okay, so the regular price, $27. So now we know what the regular price is. So this time we're going without a coupon. How much is it going to cost per person? Because we're going to divide that regular price by 4 people. Obviously, we're going to divide it amongst us. $27 divided by each of those 4 people evenly would give you a cost of $6.75 per person. Step 1 right here, step 2 right here. Well, the step 1 was our verbal model, but literally for solving it, we have to do a 2-step process. Okay? All right, let's look at this basketball example. A basketball player scored 351 points last year. If the player plays 18 games this year, will an average of 20 points per game be enough to beat last year's total? All right, so let's write a verbal model first. Okay, so we know that we're going to be figuring out if we can be greater than 351. We know that we want to beat last year's total. So it's going to have to be something that's going to have to be greater than the points last year or last year's total. Okay, so here's our verbal model. Our number of games times the points per game equals last year's points. Now we don't really want to equal, we want to at least equal or we really want to beat it. So we have to be greater than last year's total. So instead of an equal, maybe this should have a greater than sign. Okay? The number of games times the points per game. So we don't know the points, the average points per game. We're just asking if this is going to be a solution ultimately. We need to know if that's going to be enough. So here's our inequality to help us check our possible solution. 18 games times points per game will give us greater than 351 total points. So let's check it. Let's see if 20 points per game will be enough. So check that 20 is a solution of the inequality. 18 times p is greater than 351, and because 18 times 20 is 360, and 360 is greater than 351, 20 is a solution. Okay? Pretty simple. All right. Hopefully if you have questions, please bring them to class. The homework assignment is fairly simple. Sometimes I make the notes difficult, or they might seem difficult because I go through a lot of detail, but I do that on purpose to give you a lot of information so that you understand the mathematical reasoning behind things. And you should have this written down so that when you do an assignment, you can do all parts of the assignment. Each section we assign you goes with each section of the notes, so you should have examples to refer back to in your notes to help you with these assignments. All right, here's your daily homework quiz problems. There's only 2. You don't have to write the problem if you would like. You can just write the answer. And you're going to be writing an equation or an inequality. So here are your 2 problems. Write the inequality or equation for number 1, and then check whether number 2 is a solution. Check whether 2 is a solution for number 2. You can pause the video or stop the video, and then bring your notes to class tomorrow. Thanks.